This is lab number 1, and this is the tape experiment. To start off, the purpose of doing this lab was to determine how much excess charge was on a piece of tape, and we were exploring how charges interact and how charges can be seen as point-like particles, but also how we can create dipole interactions and how those interactions interact with each other. And what I found was that there was a negative excess charge on the piece of tape of 1.567 times 10 to the negative 8 coulombs. Now, to determine if the charge is negative or positive of this piece of tape, well, first we had to apply a charge to the tape. So we put the tape down, we put a piece of tape on top of it, and ripped it off. And through that interaction, created a negative dipole. We know it is negative because when we do the pin test, the pin being any odd pin, we just rub through our hair, and then that induces a negative dipole. And then we put that up to the tape, and they repel each other. We know they're negative. The second part of the experiment, we did floating tape, and this was actually much more helpful than the pin test. The pin test just determines the charge, but for this, we know the weight of the tape, we know the length of the tape, and then we can determine how strong that field is and the force on that piece of tape that's floating now. So we got the tape to float. We do the same thing we did in part 1. In this case, we know how long the tape is, and we know how far it's floating above the other piece of tape because they're both like charges. They're both negatively charged, and they're repelling. So again, my piece of floating tape was 0.35 meters long, was floating at 0.35 meters, and the tape was only 0.2 meters long. And to find how strong the field was, of course, we used Coulomb's law, and then we used Newton's law of gravity, the second law, F equals mg. We know that like charges repel, so we know that we're repelling each other, and the charge is negative when we hit the pin. Then we can solve using the field equation to see how strong that field is, and then we can see the force on that because we know the charge, we can just multiply by the field. The questions I took away from this is, why does contact between the tape matter? Well, there's constant electrical interactions, whether it be between our skin because our skin's a conductor, or humidity in the air. And then how does inducing a dipole matter? In the sense that how does static electricity work? In the sense that we're rubbing two things together and inducing dipoles. My conclusions was that most everyday objects are neutral until something is acted upon them. We know that from Newton's law, and we can see that we can induce poles in something because they need an interaction within our universe in order for them to move or change its E field or charge. And we know the tape was negative because it was repelled by the pin. The charges did not attract each other.